Today, we're going to talk about how to solve an inequality. Here, our first example is x minus 3 is greater than or equal to negative 2. We solve an inequality just like we solve an equation. So to solve this, I'll start off by adding 3 on both sides. Bring down the x, bring down your inequality symbol, and negative 2 plus 3 is 1. So here I see that x is greater than or equal to 1. In number 2, I have b divided by negative 7 is greater than 2. Solve this just like you would an equation. You need to multiply the equation, or the inequality this time, by negative 7 on both sides. This leaves me with b. And if you multiply or divide both sides by a negative number, the inequality symbol flips around. So instead of greater than, it becomes less than. And then 2 times negative 7 is negative 14. So b is less than negative 14. Alright, in number 3, we have a two-step equation. Negative 3x plus 6 is less than or equal to negative 3. When we're solving an inequality, one of the things I like to do first is to get all the variables on the left side and the constants on the right. So here the variables are already on the left. My constants are 6 and negative 3. So I'm going to move the 6 over here to the right-hand side. To do that, I'm going to subtract 6 on both sides. I knew to subtract 6 because positive 6 minus 6 is 0. This leaves me with negative 3x. Bring down the inequality symbol. And negative 3 minus 6. This means negative 3 minus 6 that way, which is negative 9. So negative 3x is less than or equal to negative 9. From here, I can solve for x by dividing both sides by negative 3. So this leaves me with an x, and because I'm dividing both sides by a negative number, it becomes the greater than or equal to symbol. It flips. Negative 9 divided by negative 3 is positive 3. So x is greater than or equal to 3. In the next example, I have the quantity 3a plus 8, all divided by 2, is less than 10. In order for me to solve this one, this 2 in the denominator is causing a problem. So instead of dividing by 2, I'm going to multiply by 2 on both sides. So that leaves me with 3a plus 8. I multiplied both sides by a positive number, so that has no effect on my inequality symbol. The only time this inequality symbol flips is if you're multiplying or dividing both sides by a negative number. Solve for 3a by subtracting 8 now on both sides. So I see that 3a is less than 12. And now to figure out what a is, I have to divide by 3 on each side. Notice that the inequality symbol does not flip around here because I'm dividing both sides by a positive number. The only time the inequality symbol flips around is if you're multiplying or dividing both sides by a negative. Let's try a more difficult one. In number 5, I have parentheses. Before we can do anything, we need to get rid of the parentheses. So over here on the left-hand side, nothing is affected. There's no parentheses, so I'm just going to bring that down. The first set of parentheses says 2 times the quantity x plus 3. So I use my distributive property. I'm going to say 2 times x to give me 2x. And then I'm going to think of this as positive 3. 2 times positive 3 is positive, so I'm putting a plus, positive 6. Over here, if I cover all that up, it looks like negative 2. So I'm going to think negative 2 times negative 1. Well, that's positive 2, so I'm going to put a plus 2. And then I'm going to think negative 2 times negative x, or negative 1x. That would be positive 2x, so I'm putting a plus 2x. Now, this is a little bit unique because now I have like terms on either side. On the left, I don't have any like terms there. 7 plus 3x cannot be combined. But over here on the right, this 2x plus 2x can be combined. So the left-hand side is going to stay as is. 2x plus 2x makes 4x. And then the 6 and the 2 here can also be combined. I'm going to think of this as positive 6 plus 2. Well, that would be positive 8, so plus 8. Now, in this case, I have variables on both sides. So to get the variables on the same side, either 3x needs to move over here with 4x, or 4x needs to move with 3x. My suggestion is to just always move all the variables to the left. So I'm going to move the 4x to the left-hand side. When you are moving a variable or a number from one side of an equation or inequality to another, you need to add or subtract. Here I'm going to subtract. I knew to subtract the 4x because 4x minus 4x is 0. This leaves me with 7, and positive 3x minus 4x is negative 1x or minus x. Bring down your inequality symbol, and this leaves me with a plus 8 or a positive 8. Now that the variables are on the left, the constants, which in this case are 7 and 8, need to be moved to the right. Again, when you are moving a number or variables, you're either adding or subtracting it from both sides. Here I'm going to subtract 7 on both sides because 7 minus 7 makes 0. This leaves me with negative x less than or equal to 1. Now, we're almost finished, but the coefficient of x here is negative 1. So I need to change that so that x has a positive 1 as its coefficient. So I need to divide both sides by negative 1. Negative 1x divided by negative 1 gives me 1x, which we know as x. And I'm dividing both sides by a negative, so the inequality symbol becomes greater than or equal to. 1 divided by negative 1 is negative 1. So my answer is x is greater than or equal to negative 1. Let's try another. Alright, so I've got parentheses again that I need to get rid of, and I can use the distributive property to help me do that. So I'm going to start off by saying 5 times 2x, which is going to give me 10x. 5 times negative 6 is negative 30, so I'm putting a minus 30. Now here's the tricky part. If you cover this up, it looks like negative 7. So I'm going to say negative 7 times x and give me minus 7x. Then I'm going to say negative 7 times positive 7, which gives me negative 49 or minus 49. Keep the greater than, and over here we're just left with 4x. Now look for like terms. Over here on the left, the 10x and the minus 7x are like terms. So 10x minus 7x is 3x. I also see I have a negative 30 minus 49. I think negative 30 minus 49. That's what I'm thinking. Remember, keep, change, change. So that would become negative 79 or minus 79. Bring down the greater than symbol and the 4x. Okay, now we want to get all the variables together, and I suggest we always get them together on the left. 3x is already on the left, so the 4x needs to be moved. When you're moving a variable or a constant from one side of the equation to the other, we either do that through adding or subtracting. Here I'm doing it through subtracting because 4x minus 4x would be 0. 3x minus 4x is negative 1x or just negative x. Bring down the minus 79 greater than. You have to have a number here. The 4x minus 4x canceled out, made a 0. So you say nothing is left, or we could say 0 is left. The variables are on the left, so we should get the constants on the right. So we need to move the 79 to the right-hand side, and I can do that by adding on both sides. So I have negative x is greater than 79. The coefficient of x here is a negative 1. That's the same as negative 1x. So to get this to be just x, I need to divide by negative 1, which I have to do on both sides. If you multiply or divide both sides of an inequality by a negative number, the inequality symbol flips, so that becomes a less than sign. And 79 divided by negative 1 is negative 79. So x is less than negative 79.